Okay, here comes a doozy. So we've got a street light is at the top of a 17-foot tall pole. So let's put a 17 there. And a woman 5 foot tall. So we're going to make a little triangle out of the woman here. And we'll have a little triangle right here. And the woman is, what does it say? 5 foot tall woman. She is 5 foot tall. Um, Walks toward the pole with a speed of 5 feet per second. We'll come back to that. How fast is the shadow? This is her shadow right here. It's a beautiful picture. I don't know who did this, but this is very good artwork. How fast is the shadow shortening when she's 35 feet from the base of the pole? And then how fast is the tip of the shadow moving on the ground? These are classic questions. I just think it's interesting, fun problem. I don't know if you're feeling the fun, but I like these kind. I think it's just cool. So basically, you get the idea. As she goes towards, the pole, and the light is shining. Do you see how here's her. Her shadow's going to get smaller than it is back here, right? As she goes towards the pole, the light's hitting her head, making the shadow on the ground. It's going to get smaller and smaller. That's what they're asking us. The shadow is going to shorten. Okay, so let's get down to it. We know our steps that we always need, and that is step number one, find the rate letters. So what rates are being talked about in this problem? Well, street lights top at 17, that's not a rate. 5 foot tall, that's not a rate. Towards what speed? There we go. Speed of 5 feet per second. So she's walking towards the pole at 5 feet per second. Okay, so there's our first one. So we can call from here to here X. So you got to be really clear. See how I put that? I don't just write like X in general, like X. Like what is that? Be really clear. Specifically, X is from here to here. And this speed of 5. That means dx dt here. Let me just slide it down here. That means that, I guess I'll put it down here. Dx dt is -5 because why? It's decreasing, shrinking, right? Meaning not her shadow, but the distance that she is from the light pole, the x we're calling, right? That distance between her and the light pole. If she's going that way at 5 feet per second, she's walking toward the pole, then this distance is shrinking. That's why it's negative. It's decreasing 5 feet per second. Okay, there's the first one. Let's keep going. How fast is the shadow shortening? So now they're asking us about the rate of the shadow. So we're going to need to put that in here. That's going to be right here, from here to here. We'll call that y. And that's the length of her shadow. And that's what they're asking us about. What is dy dt? But they want a positive answer only. So dy dt. So let me write that in. Dy dt. They want that, but they want it positive only in the end, even though it'll come out negative because it's shrinking. Okay. Um, and then eventually it's going to say, well, we'll get to that eventually. That's it for now. How fast is the shadow shortening? Then how fast is the tip of her shadow moving? We'll get to that. Let's just hold off on that one. Okay. So step one, find the rate letters. We got them. Step two, write some kind of equation relating only those letters. In this case, X and Y, right? Related rates. We got to relate some kind of equation relating only X and Y because those are our rate letters. Well, how can I write some equation relating only X and Y? Well, this one's going to be similar triangles. And here's what I mean. Left is to bottom as left is to bottom. See how the big triangle and the little triangle are similar triangles? Again, I'm going to go left is to bottom. It's going to be a consistent, similar triangles. Similar triangles. Left is to bottom. So I'm going to go 17 is to x plus y, right? That's the left is to the whole bottom is equal to the left of the little triangle to the bottom of the little triangle, which is y. There we go. The left of the big one to the bottom of the big one is going to be equal ratio. Left of the small one, bottom of the small one. Got to be equal. So then we can go diagonal, diagonal, cross multiply. We get 17y equals 5 times x plus y, just like that. Or 17y is 5x plus 5y. There's a relationship between x and y. So, okay, there we go. Yeah. Now, yeah, let's go for it. 17y equals 5x plus 5y. So 17, wait, I already forgot it. 17y is 5x plus 5y. Oh, wait, I can clean that up. Okay. 17y is 5x. So let's clean that up. Subtract 5y from both sides. I didn't even notice that till now. Boom. So boom. So we've got what? 12y is 5x. Nice. So there's a simple relationship relating only x and y. Very nice. Very nice. Very elegant. Okay, step 3. d dt. Both sides. Take the derivative with respect to time of both sides. So here we go. d dt of this side and d dt of that side. So it's like going to be 12 dy dt. You know, the constant numbers just sit there. 5 dx dt. There we go. That's nice. Okay. So step 4, plug in the numbers. Well, do we know dx dt and dy dt? I mean, we're probably trying to find one of them. So let's go take a look. Dx dt and dy dt. So well, we're looking for dy dt, and we know dx dt is -5. So dx dt is -5. So this will be and we're looking for dy dt, right? Yep, right here. Looking for dy dt, dx dt is -5. Okay, solve for dy dt. Divide both sides by that 12. Whoops, that was weird. Boom. So then, dy dt is minus 25 over 12. Minus 25 over 12. And you can divide that in your calculator. What is that? 25 over 12? I don't even know. Go to Desmos here. 5 over 12 minus 25 over 12. I get that, or I could do that. Yeah, I guess I could just leave it as a fraction, or minus 2.08333 minus 2.08333. Okay, is that what they got for the first answer? Yeah. Oh, they wanted positive. So 2.083. Good. We got that. Okay. Now for the second part, which actually will be really easy once we've got this first part. So the second part now, it's saying that it wants how fast is the tip of her shadow moving when she's 35 feet from the base of the pole. Notice we never had to use that 35 up to now. We don't have to use it at all. 35 is just extra information we don't need. So anyway, how fast is the tip of her shadow moving? Well, here's the tip of her shadow. Let's put that in real clear here. Let's make it red. Purple. How about that? Purple. Here's the tip, the shadow tip. What's happening? As she runs towards the light, what happens? X is shrinking and Y is shrinking. They're both shrinking, right? They're both shrinking. She's getting closer to the pole, so the distance she is from the pole, X, is getting smaller. And as she does that, her shadow is shrinking as well. So what makes the tip of the shadow move along the ground? Both those things. Do you realize that? What makes the tip of this shadow move? Well, just as she herself goes towards the pole, she drags her shadow with her at that same rate. But also, the shadow is shrinking. So it speeds it up even more. So both those things together. So that the tip of the shadow, here, I'll just do it right here. Tip of the shadow is going to be dx dt plus dy dt added together. It's got to be. I mean, the positive versions of those, right? We just found this one's dy dt is 2.083. And what's dx dt right here? Find out, again, the positive version. Add that up, 7.083. That's how they got that. Is that making sense? If you wanted, you could say, well, wait, they're both technically negative. And this is a negative answer. That's really, I guess, what we should say. Meaning x is shrinking 5 feet every second, right? The distance she is from the pole is shrinking 5 feet every second because she's running towards it 5 feet every second. So every second she gets 5 feet closer and x shrinks by 5. The change in x is 5 feet per second. And her shadow shrinks. We actually got negative down here, right? Negative 2.08. So her shadow shrinks 2.083 feet every second. So together, her shadow's moving on the ground closer to that pole, 7.083 feet per second. But they want the positive answer. So there we go. Because both this is shrinking and this is shrinking. So together, they make the tip move along the ground at those combined speeds. And there we go.